Hello, my dear students. We have been studying the temperature dependence of the rate of reaction, and in that, yesterday we have studied the Arrhenius equation. Now we are trying to study the two condition where if we have two different temperature and if we have two different rate constant, how we can derive the equation. So using this equation we can calculate the activation energy or we can calculate the Arrhenius factor. So let us try to study the same. Suppose for two different temperature T1 and T2, the rate constant for the same chemical equation is K1 and K2 respectively. As the chemical reaction is same, activation energy is same, gas constant R is also same, and Arrhenius constant A is also same. So we can write for K1 is equal to A into e to the power Ea upon R T1, and K2 is equal to A into e to the power minus Ea upon R T2. So we can, if we take the natural log from both the side, we can write ln K1 is equal to minus Ea R T1 plus ln A. This is your equation number 1. Ln K2 is equal to minus Ea upon R T2 plus ln A. This is your equation number 2. Let us take equation 2 minus equation 1. So we can write ln K2 minus ln K1 is equal to minus Ea upon R into 1 by T2 plus ln A minus Ea upon R into 1 by T1 plus ln A. Therefore, ln K2 by K1, because ln x minus ln y is equal to ln x divided by y. So we can write ln K2 minus ln K1 is equal to ln K2 by K1 minus Ea upon R T2 plus ln A. This minus and minus turns plus Ea upon R T1, and this plus into minus turns into minus ln A. Now you can see here plus ln A minus ln A turns into 0. Therefore, your ln K2 by K1 is equal to minus Ea upon R T2 plus Ea upon R T1. This, if we write positive sign term, if we write first, ln K2 by K1 is equal to Ea upon R T1 minus Ea upon R T2. If we take Ea upon R common, we can write ln K2 by K1 is equal to Ea upon R into 1 minus T1 divided by 1 minus T2. And if we take T1 T2 as an LCM, but we know that ln x is equal to 2.302 log x. So instead of ln K2 by K1, we can write 2.303 log of K2 by K1 is equal to Ea upon R into 1 by T1 minus 1 by T2, and therefore we can write ln K2 by K1 is equal to Ea upon 2.303 R 1 by T1 minus 1 by T2. If we take T1 T2 LCM, we can write log of K2 by K1 is equal to Ea 2 divided by 2.03 R T2 minus T1 divided by T1 minus T2. My dear students, using this equation, we are going to solve so many numericals. Now, my dear students, look at the Arrhenius equation. K is equal to A into e to the power minus Ea upon RT. Here, this term minus e to the power minus Ea upon RT represents the energy factor. This A represents the orientation factors. For any biomolecular reaction A plus B that gives products, the rate of reaction can be expressed as rate is equal to ZAB into e to the power minus Ea upon RT, where ZAB is called the collision frequency, that is the number of collision taking place per second per unit volume are known as the collision frequency ZAB. That is this ZAB for the reactants A and B, and e to the power minus E upon RT represents the fraction of molecule having energy greater than or equal to Ea, that is the activation energy here. Now, when we compare the above equation with the Arrhenius equation, we can come to know that A is related to collision frequency. ZAB is the collision frequency, but all collisions are not effective and they cannot be converted into products. We have already studied the definition of the collision frequency, effective collision, that is the collision with sufficient amount of energy called threshold energy and proper orientation that brings to the breaking of old bonds and formation of new bonds, and this kind of collision are known as the fruitful collision or effective collision. To account for the effective collision, another factor P called the probability or steric factor is introduced. So I clearly informed that even if the energy is more than or equal to the threshold energy, and if the orientation is proper, it is possible, it is probable that the collision are converted into products. So here, to cover up this probability, we have introduced the new factor, which is the probability factors, or called the probability factor or steric factors. It takes in the account for the effective collision molecule must be properly oriented, and now we can write the new rate equation. Rate is equal to P into ZAB into e to the power minus EA upon RT. Now we'll study the drawback of collision theory. Uh, this collision theory considers the atoms or molecules to be hard spheres, so it ignores the structural aspect of the molecules or ions or the atoms, and this is the drawback of the collision theory. Now we'll study some numericals based on the collision theory. My dear students, these numericals we will study into the next video. Thank you and have a nice day. Happy learning.